All right, today we're going to be going over radicals. You can also call these square roots, and this is lesson 11.1 in your books. So this is the radical sign. Remember, when I have an exponent of 2, we call that squared. So 3 squared means 3 times 3. So 3 squared is 9. 3 times 3 is 9. So the square root is the opposite. I use the radical sign. If there's no number here, I assume that number is 2. That's called the index. And what this means when I use the radical of 9, the square root of 9, it means what number times itself equals 9. So what number times itself equals 9? Well, I know 3 times 3 equals 9. So the square and the square root are opposites. Just like addition and subtraction are opposites, or multiplication and division are opposites. So I have several examples here. Square root of 25. Well, what number times itself equals 25? That would be 5. Now for this one, I have the square root of 49, and notice the negative is on the outside. What that means is that I find the square root of 49, and then at the end I add the negative. So what number times itself equals 49? Well, that's 7, and then I add the negative, that's negative 7. Now here the negative is on the inside. So what this means is what number times itself equals negative 16? Well, if I do 4 times 4, that equals positive 16. Well, how about negative 4 times negative 4? Well, that also equals positive 16. So there was no number that you can multiply times itself to equal negative 16. So anytime the negative is inside the radical, we get what we call an imaginary number. Since you have not yet learned imaginary numbers, what we're going to do is we're going to write not real. So anytime the negative is inside the radical sign, your answer is going to be not real. No real answer. If it's on the outside, you can solve that and then just add the negative at the end. Outside, solve, add the negative at the end. Inside, not real. So anytime you see a negative inside, your answer is going to be not real. Now, in your book, on page 451, there is a list of all of what we call the perfect squares all the way up to 20 squared. You really need to memorize that list. If you memorize that list, it'll make this whole chapter much easier for you. If you don't memorize the list, it's going to make it a lot harder. So for example, you need to know 1 times 1 is 1. That should be pretty easy. You probably already know a lot of these. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. So on all the way up to 20. You probably know them at least up to 10, maybe up to 12 or 13. But you need to know them all the way up to 20. That will make this lesson a lot easier. So memorize those squares on page 451. So anytime we have a number that has 2 numbers that are the same that multiply together to equal that number, we call that a perfect square. And it's called a perfect square because it makes a square. So for example, 16, if I have 16 blocks, that means I have 4 by 4. 4 times 4 equals 16, and a 4 by 4 figure is a square. That's why it's called a perfect square. I could do the same thing with 9, the same thing with 25. Any number that has 2 of the same numbers that multiply together to equal that number, we call a perfect square. So 25 is the perfect square because 5 times 5 equals 25. 64 is a perfect square because 8 times 8 equals 64. Now, every other number that doesn't have 2 of the same numbers that multiply together to equal it, if we do the square root of that number, we don't get a whole number answer. We get a decimal that keeps on going on forever. So we call that irrational. So for a perfect square, if I take the square root of 16, I get a whole number, 4. But if I do the square root of 15, there is no number that can multiply by itself to equal 15. So it's going to be an irrational number. The answer would be a decimal that kept on going on forever. So if I have a number that is not a perfect square, what we're going to do is we're going to estimate between which two numbers that answer is going to be. So the square root of 32, there is no number that can multiply by itself to equal 32. So I have to go back to my perfect squares and figure out between what two numbers that are perfect squares is 32. Well, I know 5 squared is 25 and 6 squared is 36. So 32 is between 25 and 36. Now I can't write 25 and 36 because I want to write the whole number answer to the square root of 25. So the square root of 25 is 5 and the square root of 6 is 6. So my answer would be it is between 5 and 6. Because 5 squared is 25, 6 squared is 36. So the square root of 32, whatever that is it's going to be somewhere between 5 and 6. So when for your lesson 11.1, that's what they're asking for numbers 10, 12, and 14. You're going to have to give two answers. Between what two numbers is this square root? So you're going to have to find the perfect squares and then give the answers to those perfect squares that are around them. So using that page 451, those perfect squares will really help you with those questions. Sometimes they want you to be even more specific. So instead of just giving between what two numbers, they want you to give to the nearest tenth what the answer is going to be. So how do you do that? Well, let's stay with the square root of 32. I know it's between 5 and 6. So it could be 5.1, 5.2, 5.3, 5.4, 5.5. It could be any of those numbers between 5 and 6. It's not going to be 6 because it has to be less than 6 because 6 squared is 36 and this is 32. And it's going to be bigger than 5 because 5 squared is 25. So the first thing I want to do is I want to figure out which one is it closer to. Is it closer to 6 or closer to 5? So I say, is 32 closer to 36 or 25? Well, 32 is 4 away from 36, and 32 is 7 away from 25. So it's going to be closer to 36. That means it's past halfway. Well, what's halfway between 5 and 6? 5.5. So I know it's farther than 5.5. So what I'm going to do is I'm going to take some guesses. So for example, I'm going to try 5.6. So I'm going to do 5.6 times 5.6, and that's going to give me, I'm not going to multiply it all out, but you should. 5.6 times 5.6 is going to give me 31.36. Then I'm going to try 5.7 times 5.7, and that's going to give me 32.49. So you want to keep multiplying the numbers together until you find the one that is below it and the one that is above it. So notice this 31.36 is less than 32 and 32.49 is bigger than 32. So you want to keep multiplying your decimals until you find the one that's below and the one that's above. Now, which one do I choose? Well, again, I choose the one that's closer. So what's closer to 32? 32.49, that means it's 0.49 away, right? Or 31.36. How far away is 31.36? Well, I'd have to subtract. So I subtract 32 minus 31.36, and I would get 0.64. So 0.49 is smaller than 0.64, so it's closer. So my answer would be 5.7. And for when it says to the nearest tenth, like for numbers 16, 18, and 20, you're only going to have one answer, the one that is closest, and it's going to be a decimal with a tenth. So when it says between what two numbers, I have two numbers, the one that is between, and then when in the decimal, it should have something like that. Now, when you're solving radicals, we have to follow the order of operations. So if you remember, my order of operations is please excuse my dear Aunt Sally. Parentheses is first. Parentheses doesn't just mean parentheses, it means anything that is inside. That includes inside the square root. So if there is things inside the square root, I do that first. Then I do exponents. Exponents include square roots, so exponents or square roots. And then I do multiplication or division left to right. And finally addition, subtraction left to right. So here I have the square root of 64 plus the square root of 25. So I have square roots or exponents. I'm going to do that first. So the square root of 64 is 8. The square root of 25 is 5. Now I can do addition, so my answer is 13. Here I have the square root of 72 minus 23. But notice, it's not the square root of 72 minus the square root of 23? It's the square root and then inside 72 minus 23. So since 72 minus 23 is inside, even though it's subtraction, it's inside, so I have to do that before I do the square root. So I'm going to do 72 minus 23. That's going to give me 49. Now I can do the square root, so the square root of 49 is 7. Okay? So if there was any addition or subtraction or multiplication, if there's anything inside the square root, always do that first, then take the square root. But if there's nothing inside the square root, then do the square root first before doing addition and subtraction. Now down here, notice this is inside the square root, and then notice there is nothing between this and the square root. There's no addition or subtraction sign. What that means is that negative 4 is being multiplied by the answer to the square root. So first I'm going to do inside the square root. I'm going to do 116 minus 35. That's going to give me 81. So I have now, I'm going to rewrite everything. Now I solved inside. Now I do the square root, which is 9. Remember, since there's nothing between those, that means negative 4 is being multiplied, not added or subtracted, multiplied by 9. So negative 4 times 9 is negative 36. So that is my answer. So do inside first, then do the square root. If there's nothing between these, you're doing multiplication. Now, if there was an addition sign here, then I would be adding. But since there's nothing between them, it's multiplication. Let's look at one last one before we finish for this one. So here I have a division problem. But remember, anytime I have a fraction, I'm going to do the top, then do the bottom, and then reduce. So I'm going to do the top first. The square root of 9 is 3. Notice there's nothing between 2 and square root of 9. That means 2 is being multiplied by 3. So I have 6 on top. The square root of 25 is 5 on bottom. I can't reduce that. You don't have to make it a decimal. You don't have to make it proper. Just leave it as an improper fraction. So anytime you have a fraction, do the top, do the bottom, and then just reduce. And if you can't reduce, you can leave it improper. And that will be your answer. That's all for this lesson.